Going to Costa Rica in 2 weeks.
That's you. I'm here.
Testing.
Think I made it go?
Can you hear
Oh, I
me?
can't hear you. Hold on. Keep talking.
Mersey dotes a
Yeah.
dozy
There
dotes.
we go. Okay.
Okay. So I was asking, are you going to Costa Rica in 2 weeks?
Uh, 3
3 weeks?
weeks ish. Yeah. Yeah.
Okay.
Yes, I am. And
That is excellent. I look forward to stories of bugs.
uh, um, yeah. Yes, there will be bug stories. Let me see. I'm gonna move you. Apologies. Costa Rica is awesome, and I really like it, and
Good.
I can't wait to go back. And but I don't know about you, but don't you find like your life is so scheduled and organized in advance, and you have so many things that you have to do all the time, and you're always
Yeah.
just under this constant hailing storm of busyness, that these things sort of sneak up on you, and you're like, oh, I've got to go to Costa Rica today.
Yeah, yeah.
I mean,
And we sometimes like it seems like all we do is play on the internet. But like I was looking at my schedule and I have four different events scheduled for Saturday, which is the day I don't schedule
mhm,
things.
mhm.
And it's just a matter of like, this group of humans is only available at 8 a.m. Saturday morning
That's
because
that's my
the
Sunday
planet
morning. I
rotates.
have I have a podcast interview, and then I have another podcast interview. The first one starts at 7 a.m. on Sunday, and the next one's at
Yeah.
8 a.m. on Sunday.
Yeah, so that's kind of my Saturday, where it's an 8 a.m. telecon, a 10 a.m. foundation board meeting, and then I'm recording two
Yeah,
podcasts in the afternoon. And WTF, it's Saturday. And for you, it's Sunday. So
yeah.
yeah.
I'm gonna say hi to a bunch of people. Hello
Okay.
to Andy Cowley, Ben Kalo, Bill Sugden, Bor Clankar, Ches K, Colin Jones, Elad Avron, Eric Knapp, George Lancaster, Giselle Sabarin, Gordon Dewis, Guido Bibra, Harry M, Janelle Duncan, John Drake, John Seffield, Jorn Albert, Kevin Ayers, K Spence 303, Kylie Cerna, Magnus Thymer Jensen, Mr. Tom Harvin, Nancy Graziano, Nicholas B, Nichols of the Yard, Richard Hayes, Rich Schwartz, big crowd today. Roger Haskins, Sergio Botero, Soviet Refusnik 1 Golem, and Zapvan. Hey, everybody.
Golems are terrifying. I'm just
Really?
gonna say that. Yes. Do you know the concept of what a golem is?
Sure. I know both the actual historical concept of it, but also the Dungeons and Dragons one, which is the one that we
Yeah.
mostly dealt with. Iron, flesh, clay. Oh, there was one other kind of golem. Stone?
So
Hmm.
so out of Jewish mythology, they can be made out of anything. And
The
out of so many different books I've read, they just basically have a way of taking on a spirit of their own and
The
saying
iron ones were the
things.
toughest ones, as I recall, in Dungeons and Dragons. So there you go.
So I am going to be thanking our Patreon patrons at the end of this episode. So stay on, all you Patreon people. I'm going to start reading your names this episode. Just keep cycling through
Awesome.
until I've got through all of you.
Nice. Um, okay, so if you're wondering what it is that you stumbled into, this is going to be a live episode of Astronomy Cast. We're going to do the episode, and then we're going to stick around for another half hour or so and answer your questions about space and/or astronomy. So you can, so by all means, put comments and stuff into the chat and stuff, and we will gather them all up. And at the end of the episode, we will get into it. Joseph, another D&D geek, yay! Dude,
Yeah.
you have no idea. I have, I wrote books for the role playing
Yes.
industry, so
You made some of the stories told possible.
yeah, exactly. Shadowrun, Earth Dawn, GURPS. Yeah, that was my other career before doing this. And
You
also,
actually had a career in between that and doing this. You are on
yes,
your
yeah,
fourth or fifth career.
yeah. Well, this one though was almost 20 years long, so this one seems to be sticking. All right, let's uh, let's get on with it. Are you
I need
ready?
to take off the noisy jacket before
Yes.
we record.
Yeah, that would. You should not record videos with a jacket that can make that kind of noise.
I know, but it's cold in here and I had to, ow, 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 static. Okay. that hurt.
It's funny. So it's so cold here that it's really dry, and the static electricity levels are pretty high, and so our dog and Carla are constantly shocking each other, right?
Yes.
And the dog thinks she's in trouble somehow, so she'll come over
Yeah.
and she'll put her nose up to Carla and go zot, and then she'll jump away and then think she's in trouble. Yeah, and so we got a humidifier to try and balance things out because it's just
I set up another fish tank in hopes that it would help, and it is not helping.
yeah. So go to humidifier, I think. And that's been really good for Carla's eyes because she got lasers installed in them last week. I believe that's what happened. Again, that's what I think happened. Lasers installed in her eyes. Now she shoots laser beams out. Anyway.
Like a shark.
Like a shark. Yeah, exactly. She's like a shark. All right. Let us begin. I'm ready. You're ready?
Mm-hmm. I'm pressing record.
I've also pressed record. We did it.
We did the thing.
We did this one thing. Here we go. Astronomy Cast, episode 518, When the Universe Tried to Declare War on Us. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Great. Rumor has it you're going to say a bunch of names at the end of this episode.
I am. We are working on thanking all of our Patreons who have donated at the appropriate levels, which is $10 and up. So we're not going to do it all in one episode because that's a lot of names. And we are so grateful for all of you, but we're going to spread it out over a few episodes. So today is the first day of saying thank you.
All right. So if you are one of their patrons at that level, listen to the end and hear Pamela say your name. And if you're not, then you should consider it. Join the Patreon campaign, and then you will know that you are contributing to helping out with science, and you'll hear Pamela say your name. And that's at going to patreon.com/astronomycast. Yeah.
Exactly.
All right. We always say the universe is trying to kill us, but there was this one time when the universe used our own fear of nuclear attack against us, nearly setting off a global thermonuclear war. Let's try, universe. We're on to you now, or so we thought, till we made the mistake again. All right, Pamela, so you picked a pretty weird topic this week, but I'm willing to go along with it. Let's get into the times that the universe used our own technology against us to make us think we were fighting.
Yes. So as some of you may know from watching me on Twitter, I have been rewatching Stargate SG-1 in its 10-season entirety, and it is fabulous, and it brings me joy.
I should do that again. I love Stargate SG-1 so much, and to know and my forgetful memory, like how much of it stuck with you, and how much of it is like these are great new episodes.
Exactly. And last time I watched it, I was still really early in my career, and I didn't fully appreciate Samantha Carter as much as I should have. So now, as I am further along, seeing the plights of this female PhD physicist, it's just fabulous. But one of the things that gets me is over and over across the seasons, they have these, okay, we are going to self-destruct the facility. We are going to do this thing. We are going to launch that thing. We're going to blow up this other thing. Oh, wait, we misunderstood what was going on. We're fine. Ignore us over here. We didn't almost kill you.
That's a trope across all science fiction.
It's true, but they do it more often than others.
Sure, but no. Star Trek does it all the time. That this alien probe is shutting down the systems across our spacecraft one by one, and our only hope is to eject the warp core. Oh no, wait, it was trying to communicate with us. Never mind.
Yeah,
it was just really yelling at us.
So this got me thinking. This is actually one of those things that kind of does actually happen, where uh, our own inability to recognize what we're doing almost causes war. Or at least causes a great deal of panic. Any of you in Hawaii or paying attention to the national news know that a couple of years ago, while tensions were highest with North Korea, between the United States and North Korea, there was a test of the emergency broadcasting system in Hawaii that went terribly sideways when they accidentally announced this is not a test. There is a missile headed towards Hawaii. Seek shelter.
Oh, can
Yeah,
you?
yeah.
I remember watching this unfold in the news and knowing, like, when I got onto that story, already knowing that there was no nuclear attack, but I can't even imagine what it would feel like to check your phone and your phone says you're about to be nuked. And there's, you're in Hawaii. There's nowhere you can go, right? That's it. You're done. Put your affairs in order and say goodbye.
Exactly. And with this particular example, it was simply user error on the part of the poor sod who was learning how to use the emergency broadcasting system and screwed up. But the reason he screwed up is because the system allowed him to put that message out without enough different safeties in the system. And it turns out we almost started a war in the USSR. For a similar reason back in November of 1979. In this case, instead of a simple test of the emergency broadcast system, it was a test of the emergency nuke the rest of the planet system. And NORAD, they were running a test, and all the on-screen indications suddenly showed that the Soviet Union had launched an all-out attack on the United States. And so the folks had to decide, do we fire back? Do we follow the protocols? And no one thought to actually pick up the red phone and go, hey, are you trying to kill us?
Yeah.
And according to a senator who was inside the NORAD facility at the time, there was an air of absolute panic up until the moment they realized, oh, this is just like our simulator running. And after that mistake, they no longer ran the simulation on the actual active system and instead set up a offsite test facility for running these simulations.
Oh, but I think that just sounds horrible, and again, but terrifying to a small group of people who were in the office, who were I'm sure everyone was panicking as this was happening, but it didn't necessarily leak out to the larger environment. But the one, and I'm sure this is going on, is the discovery of gamma ray bursts, which we've mentioned several times in the past. So let people know how this unfolded.
So here, nuclear weapons is kind of that great concern that we all have for very good reasons. I'm just going to end there. I don't need to explain this one. It just kind of is one of those great fears that if you don't have, you have a level of internal peace I do not understand. So back in the 1960s, recognizing our ability to blow up ourselves and the rest of the world multiple times over, the United States and the USSR put into place a ban on testing above ground various supernova. And there were still concerns, though, that maybe the Soviets would find other ways to test their nukes, to advance their technology and their ability to destroy things. And one of the places that we were worried, which is very much above ground, that they would be doing their testing is behind the moon. So we launched satellites. We launched the Vela 4 and Vela 3 satellites in July of 1967. And these particular spacecraft were put into orbit 65,000 miles up, high enough up that they wouldn't be affected by the Van Allen radiation belt, which we talked about a few episodes back. And from this orbit, they'd be able to detect nuclear bomb signals and hopefully separate them out from known other sources of gamma ray bursts, such as solar flares and supernova events. Now, while they were orbiting, while they were waiting, they started detecting these signals that just didn't do the things they quite expected from supernova, didn't do the things they quite expected from the sun, but they also didn't do what was quite expected of a nuclear bomb. A nuclear bomb explosion, because it is, in the grand scheme of the universe, such a small amount of mass that is detonating and undergoing nuclear reactions, you get only a very brief and intense blast of gamma rays. What they detected was instead uh, something that had two distinct peaks in its light curve. And while it might have been a solar flare or a supernova, there weren't any that occurred that we knew about at this time. And so this led to everyone going, holy expletive, is this a nuke? Is this something unexplained? And because it's gamma ray bursts, because it's gamma rays, the gamma rays just go through the planet, no big deal. And so trying to figure out, using just two spacecraft, where the heck these things were coming from couldn't be done as an exact science. What the different spacecraft were doing was they were each listening, and then the time delay between each spacecraft hearing the signal, sensing the signal with their detectors, gave a vague notion of the difference in light travel time for the two detectors and a vague sense of where the source was coming from. But to pinpoint it, you need three, because space is three-dimensional plus time.
Right. So you sort of know the hemisphere that it's coming from, not the precise location.
And so there is this whole long period of what the expletive is going on. And do we need to have our fingers on these keys? Do we need to fire? Do we need to have a preparation? And luckily, cooler heads prevailed. And while everyone was on alert, it turned out that this was a matter of a military satellite actually conducting really cool science. And eventually in 1970, as more of these Vela satellites were launched, specifically with the goal of determining the direction, these satellites were 10,000 kilometers apart. They were able to figure out that they weren't coming from anything in our solar system. And eventually we were able to figure out that they were coming from not just external to our solar system, but from all directions in the sky, which meant they were probably coming from at least the spheroid of our galaxy, if not further out. And today, thanks to finally in the 90s figuring out what these suckers were,
Yeah.
we now know these are exploding stars and merging neutron stars.
I mean, they're still trying to puzzle out the mysteries of exactly what mechanisms will lead to a gamma ray burst, what is the underlying star that leads to it, and will probably continue for the next couple of decades to finally have a proper model of how these things work. But I love this idea that there are events that happen out there in the larger universe that are blocked by the atmosphere, X-rays, gamma rays, some forms of infrared radiation. And so we have no way to see this stuff, no way to even understand that it exists until you send a spacecraft up and it's able to detect these things. So it almost, you would feel, and hopefully as if we run across any more of these events in the future where we, people develop neutrino weapons and then we set up a neutrino detector, and although that's the opposite example because neutrinos will go through the earth just fine, but you know what I'm talking about, that we will have learned, right, that as soon as we expand gravitational wave, as soon as we figure out some new form of seeing the universe, let's just be careful and make sure that the universe doesn't have a way of being able to actually do this. And so you send up the spacecraft, you don't realize that there are these sources of gamma radiation, and then suddenly pop, 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 you detect them. And it's a pretty funny way of doing science. So I think that is one of the most classic examples where, you go up, you're not expecting this, and suddenly here's this evidence of gamma radiation, and you almost think it's a nuclear attack. Tell me more.
Now, So the thing about this example, at least, was there wasn't that moment of fingers on the keys, getting ready to launch. There was a whole lot of, should we do that? It turns out in 1995, our eagerness to do science, and by we, I mean United States and Norwegian scientists, our eagerness to do science and our inability to fully think through who we need to warn before we make a science, almost led to like the Soviet Union responding, and in this case, it would have been the newly formed Russia responding with a launch of nuclear weapons. In this case, there's a launch facility up in Norway that is used to launch sounding rockets that are most often being launched to study the northern lights, to study the aurora borealis, the interactions between solar particles and the Earth's magnetic fields. And in some cases, they're even generating artificial aurora in their studies. It's really cool research. It's really studying one of the most beautiful local phenomena in science. But there's that little thing called the rocket launch that's going on. And back in January of 1995, they didn't warn all the appropriate people of the rocket they would be launching. They tried in
They
a
didn't tell me.
investigation. Yeah, they didn't tell you, they didn't tell me. And apparently, while they told Russia, they told the wrong people in Russia, and the news never percolated all the way to the radar operators who are making sure that there are not inbound missiles fired on Russia. So when this occurred, we had this moment of a Black Brant 12 research rocket being launched from the Andoya rocket range, and it looked identical to the launch of a Trident ballistic missile.
Oh, from
This,
like a submarine or
yeah.
right.
And so Russian President Boris Yeltsin, who was notified of this by the Russian radar operators who were not in the chain of science information. And Boris Yeltsin actually summoned the nuclear briefcase, that one that you see in photos as being like chained to the wrist of somebody.
Right.
And
The
this is the
football, I
only,
think, is the American version of it. They call it the football.
yeah, it's still a briefcase chained to a human in both cases.
Yeah.
And this is the only time known. I mean, there could be other times we don't know about, but this is the only time that is known of the briefcase being activated.
Oh. Oh
And
man.
yeah. So luckily they watched to make sure that the rocket, the what they thought was a Trident ballistic rocket, was actually headed towards their airspace. And luckily we knew enough not to point even our scientific sounding rockets toward Russian airspace. And so it was near Russian airspace, but it minded its own national borders, and nuclear war was not started in the name of studying the aurora borealis.
We've had some other examples of this, not necessarily leading to the end of everything, but we've had other examples of this, like in, I think it was Norway or Russia, or people in Norway saw this really weird spiral structure in the atmosphere, in the evening. And it was this, yeah, just this huge spiral, and people were
It was
wondering what it was.
gorgeous. It
Yeah,
was seen over Scandinavia.
yeah, and what it ended up being was a broken rocket. So the Russians had launched a rocket, it had a problem, and it spun out of control and was throwing out propellant in this gigantic spiral shape as it was dying. And people were able to see this, as you say, all over Scandinavia. We see,
And we've scared the West Coast, I don't know how many
right,
times.
yeah, with the SpaceX launches.
The SpaceX launches, and also with the occasional testing of actual tridents that we test over the Pacific because it's big. We don't test them with nuclear
Right.
tips, but nonetheless, we make sure they fire periodically. And yeah, so apparently we like to scare ourselves as much as we like to scare other nations.
And you see examples of this, like when SpaceX does its launches out of the Vandenberg facility, and it flies and sends up this rocket that's easily visible from 20 million people in the region, and you see everything posted onto social media. That's when you know that's what a UFO sighting would actually look like, is tons and tons and tons of people all seeing this same event that's been completely explained by SpaceX and NASA and all the people involved, but still people are unexpected and they stand outside and they go, what is that? Do you have any other examples of the universe?
Well, so what is kind of cool is, I don't know if you realize this, but today is the 6-year anniversary of the Chelyabinsk meteor coming in and attempting to destroy the faces of a whole lot of people in the city of Chelyabinsk, because it exploded with a bright flash of light. It was a Boleid. And all these people saw a flash of light coming through their window. They stood up, walked up to the window, and discovered the hard way that sound travels slower than light, as the sound wave struck their window panes and imploded the windows towards their faces. Now, this at the time was generally not thought to be a weapon, but there definitely were moments of what the expletive. And then more recently, as figured out by the exact same group of Colombian scientists who figured out exactly where the asteroid trajectory was for Chelyabinsk using YouTube videos. Well, today we had a press release explaining a meteor that went in over Cuba. And that particular meteor was actually caught on Doppler radar, leading to a moment of, oh dear, what is that? And the realization that the trajectory it was on and the fact that people were seeing bright lights in Florida and the Keys meant this was a meteor, not a missile.
Um, Hal McKinney in the chat notes, what about every solar eclipse before Galileo? And I think that's a great example. The fact that, right, that before people could accurately predict when the solar eclipses were going to happen, they would randomly show up, and sometimes they would happen right in the midst of some major event, a battle or some big event. And so people would they would take this as a sign from the universe that what they were doing was right or what they were doing was wrong, and that they should either keep doing this or stop doing this. I mean, however they would interpret it. And it's an interesting thing that just through sheer random chance that you would happen to be out there on the battlefield when the sun disappears.
And meteor showers are another one of those things. And as someone who reads far too much science fiction, one of the plots that I've yet to see done, or at least done well, is the idea of the little green men invading during the meteor shower. You see this hit or miss. Men in Black had the idea of a meteor hit masqueraded, roach creature coming to Earth. But it's during these meteor showers that there is so much potential for people to be looking up, enjoying the incoming grains of sand and missing the incoming, man-made, rocket-made, whatever-made craft of death and doom. So here we have opportunities that are lost to mistake things for World War III for science fiction writers. Please, real world, don't do this.
We've also got examples of things that we've lost track of. There are thoughts that some of the asteroids that come close to the Earth are actually just spent rocket boosters. There was a quasi moon that was following the Earth around, and now astronomers are pretty sure it's one of the Apollo upper stage rocket boosters that was thrown out during the mission.
Still a moon. It's just man-made.
A man-made moon, yeah. We call those satellites, I believe. But still, that this trash, and you can imagine it sort of coming back to Earth and crashing into the Earth. And then go ahead.
And this brings us to an almost international incident where ISS Soviet cosmonauts, or Russian cosmonauts now, were trying to figure out, and a giant knife was involved in this, whether or not the International Space Station had been hit with a micrometeorite, had been purposefully sabotaged by Americans, or had simply had a manufacturing error. All they knew for certain is they sprung a leak and they fixed it with duct tape because that's what you do. But the hole they had to patch with duct tape was perfectly circular. And so the argument was if it was a micrometeorite, it probably would have had a different shape. Maybe they didn't know. If it had been created by a human being, it wouldn't have gone all the way through the outer insulation and it would have looked different on the outside of the spacecraft. So during what is one of the most ridiculous spacewalks of all time, where you have mission control in a very Russian way saying, just stop, just go inside, stop. But with more words than that were all Russian. You see cosmonauts not stopping and instead essentially taking the astronaut equivalent of a machete to the outer insulation of one of the Soviet capsules and digging with violence to find out what exactly happened. And there were tensions of, was this American sabotage of the Soviet part, Russian part of the International
Yeah,
Space
and
Station?
you were seeing people making these kinds of elaborate conspiracy theory responses that in fact, yeah, the Americans had were trying to sabotage the International Space Station, which is so weird, and fairly prominent people in the Russian space administration. Do we know what it ended up being?
They're pretty sure that it was a mistake during manufacturing where someone just slipped with a drill, patched it, and didn't patch it well enough. But it definitely was probably the kind of thing that someone wouldn't have fessed up to that accidentally led to an almost incident of international levels. And there were times when we were buying Soviet rocket and Russian. I'm going to keep screwing this up. I'm so sorry, everyone, for screwing this up. As a child growing up in the 80s, I had it beat out of me. It is not Russia, it is the Soviet Union. And as an adult who went to the Soviet Union more times than she went to Russia, I keep screwing this up. I'm so sorry. So while we were buying Russian rocket engines to use on American launch vehicles, there was concern that maybe some of the issues that we kept seeing were due to sabotage of the engines that we were purchasing, that they were purposely trying to foil the American space system. So it turns out the space race is one of those things where, from launching sounding rockets to looking for gamma rays, from exploding nukes, we keep doing science and we keep almost instigating international war. And for the love of all that you love, do not run your simulation software, whether it be for the emergency broadcasting system or for detecting incoming nukes. Do not run it on your live system. Have a development system. Learn from the rest of us who write websites.
And I think for the future, as we head off into space, as we start to move asteroids around, mine comets, as we start to use various exotic kinds of nuclear thrusters, just remember that it's probably not a declaration of war, that it's just people going about their business.
And maybe live stream all your launches so that everyone knows
Yeah,
what's going on.
yeah, that sounds good. All right,
Yeah.
thanks, Pamela. We'll talk to you next week.
Thank you, Fraser. There are just so many tales of human beings totally.
I haven't read the book, but apparently there's this really scary book about all the times that we almost had a nuclear war. That the fact that we even exist is a complete fluke.
And this is part of why when people are trying to figure out what to plug into the Drake equation. Oh, shoot, I forgot to read names. I'm going to add that onto this.
Okay.
Actually, let me save this, and then I'm going to add them on. This is 518?
Yeah.
Okay. Okay, I'm going to do two different files because I don't trust myself not to screw up.
Yeah, and then Susie can just weld them together.
Yeah.
And then put in that before the outro anyway.
Yeah.
No pressure, Susie.
Oh, thank you, Susie. We're so sorry. I'm so sorry he didn't screw this one up. This one's
For
totally on me.
once. Nice.
Well, it's often totally on me. I'm the one that likes to set things saving while in hotels and walk away from my computer. And everyone's like, "Where's your audio?" It's like, it's in my hotel room. Okay, so closing this file, starting a new file. Okay. And here I go into sponsorship voice. Before we go, I just want to take a moment to thank some of the amazing people that make this show possible, that make it possible for us to pay for our software, to pay for our hosting, and most importantly of all, make it possible for us to pay Susie and thus for Susie to send her kiddo to college. So you are making education possible, and it is both the education of our audience and of Susie's kiddo. So without further ado, I want to say thank you to Jordan Young, Burry Gowan, John Yorsk, Ramji Anantmalu, David Troig, The Giant Nothing, Andrew Polstra, Les Howard, Frank Trippin, Laura Kittleson, Robert Palsma, Emily Patterson, and Kjartan Sarvri. And I'm going to say more thanks to more of you next week. And I'm just going to keep doing this as long as we have new people who are our Patreon patrons at the $10 level or higher. Thank you all for making what we do possible. Okay.
All right. Awesome. Hit us with your questions, and I see some that I really like already. So Hal McKinney says, should we have a hurricane categorizing system for solar flares?
Yes,
we already do.
And I think we do.
Yeah.
It's like X flares are yep. You're going to see something, go outside, look up. Go to spaceweather.com. It is awesome and explains all these things.
Yeah. There's C flares, M flares, and X flares.
X means you get to see it at reasonable degrees north and south.
Let me see. The classification: A flare, B flare, C flare, M flare, and X flare. And they are in the peak flux range at the 100 to 800 picometer. So an A flare has 10 to the minus 7 watts per square meter. A B flare has between up to 10 to the minus 6. C flare is 10 to the minus 5. M is to the minus 4. And X is greater than 10 to the minus 4 watts per square meter. And then the most powerful flare that I think has ever been seen is X in the X20s. Let me see. The most powerful flare. Hold on, I've got to find this.
Was this the one that was in the early 2000s or the one in the 1950s?
No, recently. I mean, there probably were, like, there was the Carrington event, and there was, and they've seen material going off in the in other directions, but most powerful flare pointed at us.
And I'm going to turn on my space heater. If you can hear it, I apologize, but it is cold. I have a remote. It's currently snowing outside.
Yeah, I don't know the number, but it's in the like X22, X25, something like that. And of course, the flares. Let me see. I can't hear it at all. The kinds of flares that happen on red dwarf stars can be hundreds of thousands of times more powerful.
And then you get the events that are tied to neutron stars rearranging their magnetic fields, and those will just kill everything.
Rich Wilson asks, for those of us who left Patreon, what is the best way to send a chunk of money per year or whatever instead? People can use PayPal directly, right?
You can use PayPal directly, and the absolute best thing that you can do is send a check to us via the Planetary Science Institute, psi.edu. The address is on the website, and put in the memo line Astronomy Cast. And that is the lowest amount of fees, the uh, most effective way to do it. We just know that it's inconvenient for a lot of people. Heck, I don't think I have paper checks anymore.
Does it?
So,
No, and every time they cost so much money now. But they also
yeah,
does that fall under the 501(c)(3)? Can you get
totally
a
falls under the
right?
501(c)(3). It's entirely tax deductible where the law allows.
Right. So, and if you want to support me and you don't want to use Patreon, you can, for example, buy my book, The Universe Today: Ultimate Guide to Viewing the Cosmos, and you help out not only me, but also Dave Dickinson, mostly Dave
And
Dickinson.
if you want to, I don't have any examples on my desk right now. If you want to support me and my desire to feed students on a never-ending basis, you can support my personal Patreon, patreon.com/starstrider, or just buy my artwork on Etsy.
There you go.
It's 739studios.com. 739.
Yeah.
It's both prime and odd.
Yeah. So there you go. So there's a bunch of ways to support what we're doing. I had a lot of people who were very frustrated with what Patreon did, but I think like the magic of the modern economy of the free market is that you get to vote with your dollars. If you don't want to support via, if you think that Patreon, you don't like what they've done, then by all means, don't use Patreon. There are other ways to support us. There's other ways to support the things that you like. And in theory, this will allow competition to show up, and then you can support, then people can switch to those other methods of competition. And that's right. Like, it's all about having choice. As long as we get to choose what we support and don't support, I think it's great. And so totally.
And with what we do, you also get to support you also get to choose how you get rewarded. So, for instance, with Fraser's Patreon, it removes all the ads on Universe Today, which is really kind of worth it. Then with my Patreon, you get photos and poems that are space related and sad and endearing. With the Astronomy Cast Patreon, you get behind the scenes access to stuff. With the CosmoQuest Patreon, it's very similar, but behind the scenes to different sets of stuff.
Yeah.
So you get to pick how you get rewarded, or if you just want to throw money at us and get nothing in return, we still find ways to say thank you. Thank you.
Yeah.
We love you.
And by all means, if you want the ads removed from Universe Today, just buy a copy of the book, send me an email, and just say, with you holding the book, and I'll be glad to turn off the ads for you. No problem. Let's see. We get on some other questions. Elad Avron asks, why do flares cause EMPs again?
So an EMP is electromagnetic pulse, which is basically a flash of energy that can pass, cranking the electromagnetic field around you up to 11, essentially. And this will trigger, as you have a massively changing electromagnetic field, it will trigger all the wires around you to conduct electricity. And this in turn will fry most of them. So a massive electromagnetic pulse running through an already turned on piece of equipment will fry it completely because it's already running at capacity. If something's turned off, it still might fry it, but probably not as likely unless you did a really bad job shielding it. And so the issue is some of these events, they cause a massively changing electromagnetic field by interacting with our own Earth's magnetic field, by having high energy particles, ionized particles running along that magnetic field. Basically, you now have a moving charge that changes the magnetic field. Changing magnetic fields drive current. It's just this horrible feedback process.
And where it becomes really dangerous is the idea of it's that everything is connected. And so if as you get these electrical charges getting jammed through various electrical systems, most of them can handle it no problem, and it's fine. But if one breaks, you know how that works. If you go into your house and you cut one wire, you can kill all the lights in your whole house, right?
Yes.
Because they're all in big circuits. And that's the problem, is that all of our electronic devices are all connected together into these gigantic circuits across the entire, eastern seaboard and things like that. And so if you get enough failures across any part of this, then the whole grid goes down. And so the solution to this is to somehow be able to break up the grids into smaller and smaller pieces, so that if one part does get overloaded, it doesn't overwhelm the entire network.
Just and this is something that a lot of parts of the world that deal with a lot of heavy snow do on the local level, where you take down one power line and a neighborhood might lose electricity, but the whole city doesn't. It used to be that taking down one power line would have a much more impact, a much deeper impact on the region. Well, here, what we're worried about is events where you have the power grid running near capacity and you suddenly cause the magnetic field to rapidly change. You add additional current, and now you start blowing up those massive power grids that aren't subject to snowstorms. You start taking out the big transformers that basically unite one set of grids with another, and you take down the eastern seaboard, as has previously happened.
Yes. But fortunately, the future of power generation, as we all start to put solar panels on top of our houses, as we start to add these battery powered systems, as we get electric cars that drain and recharge and cycle power through, you can imagine that the big side effect of this is we're going to have a much more robust power system, so that those killer solar flares won't be so deadly.
Killer.
They won't be so killer. Yeah, we won't have the power go out and then everybody freezes or starves. So yeah, and there are, like, during the Carrington event back in whatever it was, 1859, it caused telegraph poles to light on fire because there was so much electricity going through them. So we are unprepared with our current status of our grid for future events. And we've seen, and they happen like once every 500 years, but we've seen them go in other directions that were even worse than the Carrington event. They just didn't hit us. And imagine the poor creatures trying to have electricity around red dwarf stars with 100,000 times as bad.
And the thing that always gets me to think about is, as we have more and more people adding solar power to their houses, they're also, in some cases, adding massive transformer and battery arrays to their houses. And if you don't have the correct kinds of surge protectors on the system, if you cheap out, essentially, you can have those massive power spikes coming into your house, essentially exploding your transformers in your house. Right. So don't cheap out on your surge protectors, people.
I did.
No.
I need. It hasn't hurt me yet, but I definitely need to get a UPS here in my house, and I don't have one right now. So, and we have terrible power. So, very. You can see it flicker when things are going on in the house or nearby. Yeah. I really should get it.
In line with today's topic, when I lived in North Austin in Texas, they have the Pickle Research Center where they test rail guns, and you could always tell when they were firing the rail gun because you'd get a brownout.
Oh, wow.
Yeah. Sorry.
Nichols of the Yard asks, could spacecraft such as New Horizons be used to more accurately determine the distance to stars using the parallax method?
Only if they were orbiting. Since they're not orbiting, no. It's like on its way out.
Yep.
To parallax, you have to have. I never have enough hands. Okay, so we're going to use my microphone as the sun, and this is the orbit of the Earth. My for those of you who are watching, I have a microphone in front of my face. I have a curved pop filter, and as the Earth goes from one side around the sun to the other side, that motion allows it to go between two different points repeatedly, and it can disentangle a object's apparent motion that is caused by parallax effect. This is what you see when you go from closing one eye to closing the other, and foreground objects move relative to background objects. so they can disentangle that motion due to parallax from the actual motion of an object moving through space. Something like something like New Horizons, which flew past Pluto, it's traveling, and as it goes, sure, it can make all these amazing observations if it had the right detectors, which it doesn't, of foreground stars relative to background stars, but it doesn't have the capacity to disentangle the actual motion of the object through the sky from the parallax induced apparent motion through the sky.
But I'm just kind of imagining here, right? Like if you sent Gaia is currently orbiting with the Earth. If you sent Gaia out to, say, the orbit of Mars, or had it go out to, say, the Jupiter L4 or L5 Lagrange point, which is gravitationally stable, or had it go out to where New Horizons is, and even, I mean, couldn't you take into account, you're exactly right, the New Horizons is on a trajectory that's going to take it out of the solar system, but the entire solar system is rotating, and so it's moving, but it's going to take like 250 years to get to the other side of the solar system for it to have that parallax.
With Jupiter.
Yeah,
Jupiter was a good one.
Yeah, for like 4 years, 4.5, 5 years for Jupiter to go around the sun. That would and a dramatically larger distance.
Yeah.
It feels like sending a super Gaia out to the orbit of Jupiter and then using that distance to do a much more accurate parallax measurement would be very useful.
I support that mission.
Yeah, that's a great
idea. It doesn't
idea.
exist. It isn't proposed, but I would support that idea.
Yeah, we just made this up, but it's a great idea. We encourage it.
Yes.
Camden Bassett asks, more of a sci-fi question, if we had the technology to merge worlds in our solar system, would it be possible to create another Earth-like planet? If so, which worlds would be good to merge?
If we could somehow, remove all of the nastiness from Venus's atmosphere, I'd say Venus and a whole bunch of icy objects that we bring in, but we bring them in rapidly enough so that they don't totally melt before they get to Venus. Mm-hmm. So give it a bunch of water, bring in some meteors to make sure you get the right isotope ratio so that the water's useful. Let's grow up Venus a little bit, pull it out to a greater distance from the sun, and it's good to go. And it doesn't require all that much changing. It's just that atmosphere is kind of poison.
I think you're exactly right. Venus is pretty much there already, right? The mass of Venus is close-ish to the mass of Earth. The gravity on the surface of Venus is close-ish to the gravity of Earth. It really, the problem is just that it has a pretty terrible atmosphere, and so if you could just cool it down, extract that terrible carbon dioxide atmosphere, you could make Venus relatively Earth-like, and you wouldn't have to add much at all. Like if you just added,
spin it up to get a better magnetic field.
I don't know whether spinning it would get you the magnetic field, but you would definitely want to spin it to at least get a better day-night cycle.
Yeah, that for sure.
But you wouldn't. So I think. And if you did smash it with a bunch of asteroids, then you could maybe reliquefy, like maybe smash Mars into Venus.
I'm not sure Mars has enough water.
No, but you want to liquefy Venus. You want to give it another crack at making plate tectonics. You want to give it a shot at having an internal magnetic field. But you're looking at hundreds of thousands, millions of years before it cools down to the point that you can use it again. So the problem with any of this merge stuff in the solar system is you then have to be patient and wait for millions of years for whatever you've smashed together to cool down to the point that you could actually use it for what you wanted. So I think Venus is the closest we're going to have. As weird as it sounds, as much as Venus is awful, Venus is like the least awful place because it has that gravity.
Yeah. And the thing that we don't know is, does it have a liquid core still? And because it's rotating so slowly, if it does have a liquid core and we spin it back up, that spinning would generate a magnetic field. And so it may be that we can just set her rotating and get back the magnetic field that she's currently missing. And when I say she's currently missing, I mean the magnetic field at Venus, there is one, it's just tiny, isn't even it isn't even generated inside of Venus. It's interacted, it's driven by interactions with the solar wind.
And you probably all know my take on this. Like, let's not try to create new gravity wells. Let's just tear them all apart and turn them into O'Neill cylinders, right? Like, why go into another gravity well? Let's just orbit the sun itself in our gigantic O'Neill cylinder.
Okay.
It's just a trap. It's a trap. Violet Skydiver asks, why haven't we launched more message in a bottle probes like the Voyager? Surely the probes there are the greater chance of aliens discovering them.
Money. Voyagers were launched because of a very specific alignment of the planets that occurred that made it possible for these spacecraft to, in one set of well calculated flybys, take advantage of the gravity and the positions of Jupiter, Saturn, Uranus, and Neptune and visit all four of these worlds. That kind of alignment just isn't going to happen again in our lifetimes. So, since those two missions, and the pioneers which tested the technologies before them were taking advantage of opportunities to do new science that had never been done. We're fairly low cost spacecraft in the case of New Horizons, which has also gone out that far. Yes, they carried messages, but that wasn't the justification for paying for them. The justification for paying for them was taking advantage of these alignments of the worlds, flying things out that could do amazing science, and just knowing that once we got them going, they weren't coming back. So let's put a message in the bottle.
Yeah. And I think also the Voyagers and the Pioneers were flyby missions. The early Mariners, all of those spacecraft were let's do a flyby. Let's see it for the first time. New Horizons is a flyby mission. Once you've done the flyby, you've taken just this big, as you said, they took advantage of this, of the fact that these spacecraft, the planets were all lined up. They could do these quick flybys. Now it's time to go back to stay. And so Cassini was what you do after the flyby. Galileo was what you do after the flyby. And so we're done with flybys. It's time to send orbiters and landers to these places. Let's send an orbiter back to Uranus, an orbiter to Neptune, a lander to Triton. Let's send an orbiter to Pluto. We had the orbiter that went
just
to Ceres
the Delta
and Vesta.
V, the pain to deal with.
Yeah. And so it's just like the days of, and it's this, you start with flybys, then you move to orbiters, then you do landers, and then you do rovers. And just think of it like a checklist and look at all the places we've been in the solar system. Just work your way down that checklist. And
you can see how we're using that checklist with asteroids as a whole, with Mars, with Venus.
Kuiper Belt objects.
The others are just further out, so it's a bit harder to do.
Yeah.
Delta V, it's our enemy.
Yeah. And so you would expect the first time we reach out for another star, it's going to be a flyby. We'll send a flyby. And then we were like, now we want to send an orbiter. And it's going to be 100 times more complicated to send an orbiter. And then we're going to want to send a lander. And that's going to be 100 times more complicated than that. And then we're going to want to send a rover. And that will just be this chain that we always do. LKSSBBWS09 asks, what would the cascade effects be of changing Venus's orbit?
It would, short term, nothing. Long term, it creates different perturbations on the orbits of the other planets. But as long as you don't stick it in a resonance with anybody, it's just going to change the long term perturbations. But short term, everything stays the same. But the issue is if you stick it in resonance so that it goes around the sun it goes around twice for every one time Earth goes around or something like that, then it's going to start interacting with orbits. We're going to start flinging asteroids in all directions. Then badness occurs. Don't put things in resonance that you like.
And you get farther out, and eventually you get these gravitational interactions between Earth and Venus, and they eventually smash into each other. So don't do it, please. 1 more minute. 1 more question. Hal McKinney asks, if and when the Earth's magnetic field actually flipped, wouldn't that qualify as the universe trying to kill us with all the radiation that might hit us? The field goes away for a while. Yeah, but like just barely. Like the universe is not trying super hard.
It's more like it's trying to evolve us, is the way I view it. Because
we've
had these magnetic flips before.
Yeah.
And they don't trigger, as far as we've been able to tell, massive die-offs, but they do increase the number of genetic mutations that are going to occur as DNA gets smashed.
Yeah.
So the question becomes, are any of these inheritable? Does it increase the mutation rate and increase the evolution rate? That's kind of a science fiction novel waiting to happen.
So we don't see uh, any correlation between polar flips, which happen every few 100,000 years, and extinction events on Earth, which means that when the next polar flip happens, we're not all going to die. But it could be that, and we don't even know how long it's going to take. Like, it could happen in a day. It might take a couple of weeks of weird magnetic field weirdness, and then the whole thing finally flips over. Or maybe it all breaks up and it's like the sun, and you get this time where there's weird magnetic fields all over the Earth, and then it flips over and settles on the new configuration. And during that
And
time, you're protected to some degree, as well as by the atmosphere.
and the geological record seems to indicate that while occasionally it occurs quite rapidly over hundreds of years, not months or years, but hundreds of years, usually it's more like a few thousand years. So, yeah, cool mutations, increased evolution, go for it.
Right. I mean, sorry to the individuals that get cancer and die in the short term, but larger scale of evolutionary progress, you're welcome.
Yes.
All right, Pamela, we've reached the end of our hour. Thanks, everyone, for watching. Thanks, as always, to our moderators. Thanks to all of our patrons, who we thanked there. Thanks to everyone at the Weekly Space Hangout crew that provide the chat that's going on down there. If you want to be a part of this amazing community, go to wshcrew.space, and you can check that out. All right, let's wrap things up. Thanks, everyone, and we'll see you all next week. People always say I shut this off too quickly. I'm going to wait and now shut it off.